If we think of daylighting as the design objective that offers occupants the most appropriate use of natural light in a particular space, the complexities of the overall task become clear. The three most significant challenges faced by the designer are control, glare, and solar heat gain. There are three basic dimensions of the control task: regulating the amount of illuminance to fit what is needed for normal work, adapting the amount of light in a space to fit multiple functions, and controlling the shifting patterns of daylight in the occupied space. Regulating the amount of illuminance critically depends on a good design that considers the many variables affecting the amount of natural light available for a given task, and then meets the objective of using natural light in a significant amount of the space. For example, one standard requires a 2% daylight factor in 75% of all primary work areas. Other controls include the use of shades and external window treatments when there is too much light, and either manual or automatic electric light controls when there's not enough. To adapt the amount of light in a space, for example to black out a room for a presentation, electric controls are used to either block out any incoming light or to augment the normal amount of light. To control shifting patterns of daylight, the contrast ratio between the task area and the surrounding space must remain constant, even as the absolute level of illumination changes. If the walls of the space are well lit and there's always an adequate amount of task lighting, the occupant will perceive the space as a whole to be lit in a comfortable way. Many urban office dwellers are familiar with the disruptive effects of the sun reflecting off a nearby building, but glare also occurs in less severe but still disruptive forms. The problem is due to both contrast and absolute light level and also varies with season and time of day. An effective control system will provide some way of at least improving the situation, for example with a user-controlled shade. Solar heat gain is a natural effect of sunlight in a space. In a residential setting, the challenge is to take advantage of it when the outside temperature is low, thus reducing heating costs. In both residential and commercial settings, the goal is to blunt its effects when the inside temperature is already nominal, thus minimizing air conditioning costs. One solution is a high-performance fenestration system. Low E coatings can be used to block the transmission of infrared radiation. Protecting the space with external shades that block infrared radiation is another solution. There are two traditional approaches to daylighting a building: side lighting and top lighting. Side lighting is the most familiar method of daylighting, usually supplied by vertical glazing systems. It is characterized by these challenges. Daylight access from the building's perimeter creates a zone of daylight because it is often difficult to provide deep daylight penetration through typical side lighting techniques. Access to daylight is highly dependent on the orientation of the building with respect to the path of the sun and significant features of the site, such as other buildings and vegetation. This makes single design solutions for such institutional designs as schools and libraries hard to replicate. Top lighting. Traditional skylights are the most common top lighting aperture. The key benefits of a top lighting system are that the design of the daylighting system can be totally independent of the building's orientation and can be designed to evenly daylight the entire floor plate located directly beneath the roof. This enables both perimeter and interior spaces to benefit from this natural light source. However, a traditional top lighting system may need between 5 to 9% of the roof area to achieve acceptable illuminance uniformity. Other challenges include the lack of easy user control of the output and the likelihood for shifting patterns of light, even with diffusing skylights. There has also been a historical problem with system leaks. A number of structural issues must also be addressed with traditional top lighting. The typical application is limited to the top floor. Skylights are difficult to reconfigure since it is hard to move drywall shafts. A complex architectural integration between the rooftop and ceiling apertures may be needed, forcing critical alignment issues between the building structure and the ceiling grid and framing. And there is potential for significant heat loss and solar heat gains to the building and occupied spaces. While the traditional approach to top lighting does provide the benefits of daylighting, it also has a number of disadvantages. However, there is a revolutionary new approach to daylighting using the top lighting strategy, the tubular daylight device. This is the essence of Solitube. Solitube daylighting systems capture ambient and direct sunlight on the roof and bring it into the structure. Because they use advanced optics and other light management technology, they're able to overcome the limitations of a skylight while adding some additional advantages as well.